Good morning, student. Today we will be seeing the last important part of the vehicle, road vehicle, which is plays a vital role in controlling the vehicle's motion or stopping the vehicles. You know that all vehicle has what we call a braking system. Now we will see what you call an anti-lock braking system, which is gaining popularity slowly. It has normally most of the vehicle has braking system. This system has additional component like actuator, this ECU and sensor, all those things, which makes the vehicle to stop without skidding. When vehicle will, generally vehicle will skid when you apply a brake, sudden brake force, which makes the rotating wheel come to standstill. But still vehicle has a inertia. You know, when vehicle is moving, it has a mass because of the when it has an inertia. When you wanted to stop the vehicle inertia, the energy stored in vehicle should be zero. Otherwise, there will be a forward motion in the vehicle body. Then that's what is making vehicle to move. Even when engine is stopped, vehicle is moving. Now, without if you apply brake, and this energy will be dissipated as a heat in the brake drum, as a frictional. So if you try to stop the vehicle suddenly, the vehicle will get locked. If you apply too much force, vehicle is not allowed to rotate. But the vehicle body has energy to move forward. So then vehicle will start skidding. To avoid that, what you have to do is you have to apply brake force on the wheels, and when vehicle wheel about to stop, you have to release the brake so that vehicle will not skid. But since you already applied a brake, some amount of energy will be dissipated. So the vehicle speed reduces. For example, vehicle was moving 60 kilometer. When you see some obstacle in front of you, apply a brake, then vehicle speed is reducing. Number of wheel rotations start reducing. When wheel is about to stop, if you are able to sense and release the brake, so again vehicle will gain momentum and the speed goes. But this time, some amount of energy is already lost. When you apply brake, you know that always we cut off the engine. We should not accelerate the vehicle, correct? So vehicle fuel will be cut off automatically. That's what we do. Okay. Now the vehicle speed, original speed from there, it may come to say 50 kilometer. You apply brake for some amount of time and vehicle wheel is about to get locked, release. Then the vehicle speed comes down. Again, you increase, apply brake for some. Again, the vehicle speed will reduce because you are stopping the wheel from rotating, not complete lock, right? So then vehicle speed, when you're about to stop, you release the brake. If you release the brake, again vehicle will start gain momentum, its speed will go. But this time it will go to only 50 kilometers, already some energy is lost. Like that, by repeatedly applying brake and releasing brake before the wheel get locked, you can slowly dissipate the energy in the vehicle, and the vehicle will come to a stop without skidding. So this method of applying brake, releasing the brake before wheel gets locked, and again applying brake, doing is called anti-lock brake system. That's what it is. So it is a braking system like conventional braking, but only thing is the system makes sure that the wheel never get locked. That means stop rotating. So that's what the anti-lock brake system. So the anti-lock brake system is shown here in this figure. You can see that there are four wheels. These are four. We are talking about four-wheel vehicle. There are four wheels. The wheels are shown here. Right? There are four wheels, and it has brake system, which is shown on this wheel brake. Right? Most of the time, it may be hydraulic or step brakes. Okay. Okay, the brake system is there. Then all four-wheelers additional, this is when driver presses, you can see that this is the brake lever, brake pedal. When driver applies a force and presses, and what he will do is he will activate a hydraulic system. These are hydraulic braking system. Basically, here what shown is a hydraulic. Most of the ABS system uses hydraulic braking system. So when the driver presses brake pedal, he activate, yeah, what do you call as a brake booster. Brake booster in turn is connected to master cylinder. Okay, you can see that there is a brake booster. When you press that, it is activated, which in turn will connected to the master cylinder. Then this from the master cylinder, the hydraulic fluid, because the hydraulic system is a hydraulic fluid. The hydraulic fluid system is released to hydraulic modulator. Okay, the fluid goes. This modulator is controlled by electronic control unit. This is called ECU. This is an electronic control unit. Okay, this electronic control unit will open the hydraulic modulator valves such that the brake fluid goes to individual wheels. Brake fluid goes to individual wheels so that the brake start applying brake force. Okay, so when the driver presses, what will do is this ECU, electronic control ECU, will generate pulses. Okay, generate control pulses. These pulses, this is electrical voltage. Right? This is time, this is voltage. For example, 12 volt signal, maybe 12 volt pulses. The pulses will be applied to the hydraulic valves, which will open the hydraulic fluid, so the brake will apply brake force. Okay, so how long the brake force will be applied? As long as the pulse is on. Okay, this pulse duration, because as long as that the brake shoes are applied, so the pulse duration is such that when the wheel is about to get locked, the modulator will stop applying brakes. Okay, these pulses, so the brake force will apply, then wheel will become free. Okay, so then you have warning lamp. This is for driver, and hydraulic line, correct? So hydraulic line is through which hydraulic fluid is going to brake system. Now, the detailed signal system of the ABS is given here. What is inside the hydraulic modulator, which is shown here, correct? This is the hydraulic modulator. So the from the master cylinder, high pressure fluid goes to the control valve. You can see that there are two valves, A and as well as C. These two are control valves, right? A is inlet valve, C is called outlet valve. You can see that the hydraulic fluid, black color light is going. The black color is high pressure fluid. The gray color line is low pressure fluid. That is a return fluid. We call this return fluid. This is the pressure, high pressure fluid. Okay. So now from the master cylinder, the high pressure fluid is connected to the valve. Okay. You can see that connected to inlet valve A. Okay. Now the inlet valve opens when the pulse is on during this duration. During this period, the inlet valve A is open. Inlet valve A is opened. The appropriate electrical signal given by the this. Okay. So the appropriate control signal is given by the ECU control unit. Okay. So now with the valve is the high pressure fluid comes from the master cylinder through this valve, and here this is the brake shoe. P is the brake shoe, wheel brake cylinder. Correct. The force is applied to the wheel. It is applied to the wheel speed start reducing. Okay. Now you can see that this high pressure fluid is also goes to C, which is the outlet valve. This valve is closed. When okay, so during the time A valve is open, C valve is closed. Okay, this is on period. Okay, that time who is giving this? ECU provide the signal. So that means braking force is applied. Braking force is applied. We have valve open, high pressure flow good. Brake, the pressure is applied to brake shoes, so wheel is applied. Okay. Now, meantime, this wheel speed sensor you can see here circling, which is shown in violet color. Wheel speed. There are 4 wheel speeds. Individual wheels, the speed will be measured, and it is given as input to the control unit. When wheel speed, number of rotation, wheel making start coming below a certain value. For example, it comes close to say 5 rotations or something like that, 10 rotations. What will happen? The ECU is always measuring individual wheel speed. So then ECU switches off the signal to the A valve A. Correct? This is a braking force applied to this one. This is control valve open. Okay. This time now, immediately the C valve will be open, A valve will be closed. Okay, this will open during this. C valve is open, A is open, A is closed. A valve is closed. Okay, so when A is closed, what will happen? The brake force is removed. So the high pressure fluid, which is correct. So further fluid will not come from the master cylinder during this period. Whatever there the high pressure fluid in these tubes, correct, in these tubes will be released and goes back to tank. Correct. This goes to tank, release back, returns to the tank. Okay. Now, when that means again speed will start increasing. When the speed increases, again after some time, again same force is applied. So that means ECU will generate series of pulses like this. Correct? Till the vehicle, how long these pulses will be created? This is on, brake on. You can say the brake on, brake off. Brake on, brake off. Okay, like this. So this is repeated 400 times per minute, 1200 times per minute. Some vehicle 1200 within 1 minute, that means within 60 seconds, this ECU will generate this on-off signal as low as sometimes 400. Depends on vehicle mass, the manufacturer decides for smooth braking without wheel locking. So it can be 400, 1200 times. So the anti-lock brake system, what is the, okay, this is the system configuration. The anti-lock brake system, which is normally called ABS, prevents the wheel from getting locked. That means ceasing to rotate during hard braking. We call sudden brake, correct? When you see an obstacle very close to you, apply full force. When you apply full force in conventional braking system, the brake shoes goes and jams on the wheel, so it prevents wheel from rotating. Correct. So, but still, vehicle has a momentum. Correct. Momentum has not come to because it has energy during the acceleration period. Okay. Then the vehicle will start skidding. Yeah. Then another thing important thing note is a rotating wheel allows the driver to maintain steering control while braking, which is avoids skidding and also traction. Okay. Now, if you apply sudden brake, in conventional manual braking, I am talking, the driver presses the brake pedal, which will directly come and apply force. The ECU will not be there. This unit will not be there. Spence sensor, all this thing. Only the master cylinder connected to this one, you apply forces. If you release this one, brake should be released. Okay. Now, in the rotating wheel, if wheel is not rotating, you cannot steer. That is another important thing. If wheel is not rotating, you cannot steer the vehicle. If vehicle get locked, that is then since you cannot steer. If there's a curvature, if you want to avoid obstacle, you can't do it. Your vehicle will go and hit because already wheel is locked. You will not be able to steer the vehicle. So that is important. So so if you allow the wheel to rotate, but slowly reduce the wheel speed, that means vehicle will come to a stand stop. That was ABS do. That's what I explained till now. Correct? Apply a brake, then vehicle, the wheel is about to stop, you release the brake so that skidding will not happen. So you can steer the vehicle, also you are slowly reducing vehicle speed. That is what ABS is doing. Then here we take improved traction. What is a traction? Traction refers to maximum frictional force that can be produced between surface of the two surfaces, between surface without slipping. What are two surfaces? Well, your wheel is there, correct? This is your wheel, is moving on the road. Between two, there's a friction, correct? There's a friction between tire surface and the road. In between, if we get maximum frictional force, then we say that slipping can be reduced, right? Without slip is called as a tractional force. If tractional force is there, means that it is controlling is better, correct? Vehicle will not skid, then control also better. Then ABS offers improved vehicle control and decreases stopping distance on the dry road, especially slippery surface, dry and also on slippery surfaces. Oil is there or ice is there on road, water is on road, because that can be work as a lubricant. Ice, water, oil work as a between tire surface and road surface there. They will slip, wheel will slip. So then traction reduces. If traction reduces, you cannot control the vehicle. Locked wheel is also when there's a slipping between vehicle tire and the road surface, then also the control becomes difficult. Vehicle control is difficult. So we need to have the maximum traction. That means rotating wheel only provides. Okay. When we talk about traction, we call it tractional effort, because that is called traction is called tractional effort, which is called as force available between at the contact between drive wheel tires and the road, as also called tractive effort. Correct? You know that here you may see drive wheel tires. We know that the vehicle is driven, most of the vehicle, if we talk about car, the engine is connected to back wheel or front wheel, not both the wheels. Correct? From engine, you have gearbox. From there, there you only call what you call propeller shaft, yeah, a long cylindrical rod, correct? Big rod, which is connected to the differential, which in turn is connected to wheels. So vehicle can be only two wheels will be driven, whether back wheels or front wheels. So if the vehicle is driven by engine in the front wheel, called front wheel driven vehicle. If it is driven by the engine is connected back wheels through the propeller shaft and gearbox, they call back wheel driven. We are talking about the wheel which are driven by engine only provides a tractive effort or traction. That's what we are saying here. The ability of the drive wheels to transmit this effort without slipping is known as traction. Hence, usable draft driver never exceeds the traction. Okay, tractive effort is always lesser than traction. Okay, then when the tractive effort F is greater than R, which is the total resistance of road. R is called the total resistance of the road, level road. The surplus tractive effort is utilized for acceleration, hill climbing, etc. Basically, we say that tractive effort is referred as F. The friction between the road and the wheel is called as R. When F is tractive effort is greater than R, then only vehicle can move, accelerate. It can move. Right? That's what we are saying. The tractive effort related to engine power using the equation given here. Right? Engine torque, TE, is nothing but 60,000 multiplied by PE divided by 2 pi n Newton, because it is a rotational force. Correct? Torque is nothing but rotational force. TE, that is engine torque. Substitute is the engine torque. The torque available at wheel is given as TW, is nothing but GR multiplied by AR into eta T into TE equal to G eta T into TE. Again, next equation F equal to tractive effort F equal to T subscript W divided by R equal to TE into G into eta T divided by R Newton. Okay, tractive effort is linear force. Correct? It is a linear force. So we are talking in terms of newtons. So many newtons. The engine torque is a rotating force. So it is given in Newton meter. Okay, we are talking of many parameters. What are those? P is called as engine power. It can be in brake BHP or in kilowatts. Correct? Engine power can be so many HPs. We call BHP. Correct? We call BHP or simply called HP. Correct? Sometimes they call BP also. Brake power, brake horsepower, or just horsepower. That is in British or American system. But in case of metric system, we call in case of watts or kilowatts. Okay. Engine power, P is nothing, engine power. Then eta T is not overall transmission efficiency. Okay. Overall transmission efficiency. That means from the engine, the torque, the rotating, this is connected to gearbox. Gearbox in turn will connected to what you call a differential. A differential and gearbox, they have gears inside. So there's a gear ratio. So the overall gear ratio is called as the transmission efficiency. Is controlling the transmission efficiency of the transmission system of the vehicle. Where GR is called gearbox ratio, AR is called axial ratio. Correct? This is at the differential. Please note the differential is a gearbox, differential gearbox. There also you have gear ratio. That is referred as AR, the axial ratio. Then between engine and propeller set, you have another gearbox. So the overall gear ratio, capital G is nothing but GR multiplied by AR. Okay. Then A is the radius of the tire. Correct. So radius. N is the RPM, rotational crankshaft. What is engine speed? Crankshaft is nothing but engine speed. Okay. Then F is the tractive force. So we can calculate this one. Tractive. What is our interest is tractive effort. Okay. So which can be calculated using this formula. As I told you, G is the overall gear ratio, product of your transmission gear ratio and the gear ratio differential that drives the wheel. Okay, that drives the driven. It is called a driven wheel. I told you the front wheel or back wheel. Any one of this will be driven by through the differential driven wheels. Okay. Next thing is, these are the fundamental thing we have to understand. Tractive effort, we know how, we saw that what is tractive effort. The tractive effort should be greater than the road resistance. Then only vehicle can move forward. How to calculate once the parameter given? Engine power is given, correct? Then once engine power is given, you can calculate the engine torque, correct? So and engine power and speed. N is the speed of the engine. This is power generated by engine is given. You can calculate engine torque, TE. Once you know the engine torque, TE, you can calculate the torque available at the wheel, TW. For which, what you need? TE already you have calculated. You need to find out, you should have the parameter gear ratio of the gearbox and also the axial ratio, which is constant. That is differential reason. Both both the data is given, then if we know the eta T is also unique, correct? Overall transmission efficiency. Gearbox also has, if you give some torque and speed, correct? Gearbox also produces output torque and output speed, correct? So input power should be in gearbox, input power should be same as output power. But generally no, because of gear has the friction loss, all this thing, some amount of energy is like gearbox losses. So the gearbox may have 90-95%. We want 10% efficiency. No gearbox will give 10%. Some amount of loss is there. That's why overall gear ratio, and also the eta T is nothing but transmission efficiency. This manufacturer of the gearbox will tell both the gearbox and also differential drive suppliers will give what is efficiency. They will give. Once you have the data and once you know then you can calculate the torque at the drive wheels. TW is nothing but GR into AR multiplied eta T into TE, which can be written G into eta T into T. So eta T is the transmission efficiency. G is the capital G is the gear ratio multiplied by axle ratio. T is the already you calculated, correct? Then our interest is finding tractive effort. Tractive effort F is nothing but the torque at the wheel divided by wheel radius. That can be calculated. Okay, so that's how we'll calculate. Once we know the tractive effort, then another important things in ABS is this is I call the basics of braking and vehicle control. There's a terminal called wheel slip. What is wheel slip? Wheel slip is the vehicle speed, actual vehicle wheel speed. Right? Then optimal brake performance will be achieved when wheel slip is around 10 to 15%. Okay. See here it is shown. What is the wheel slip? So the wheel is rotating, correct? The wheel is, for example, wheel is rotating. Okay, wheel is rotating. Then rotating and moving over the surface. Now, if good traction is there, correct? Good contact, good friction is there, which is called, we know the tractive effect, correct? If it is there, then what will happen? Then there will not be any no slip. When the no slip is there, correct? That means when if the tire makes one rotation, correct? So it will travel certain distance. But if there's a slip, when tire makes one rotation, that depends upon the radius of the tire, how much it will travel, correct? So now if there's a slip, then the tire, the vehicle will not move the same distance as when there's no slip. Okay, so then during optimal braking performance can be achieved only when wheel slip is between 10 to 15%. That's what shown in the graph. I will show that. Then during the wheel lockup, that means wheel rotation is completely stop, correct? Wheel is rotating, zero slip, correct? When wheel is locked, correct? This is locked wheel, correct? That means wheel is not rotating. That means then what will happen? Then the slip will be 10%. Correct? Slip will be 10%. When wheel is freely rotating, slip will be 0%. Okay. So when wheel is get locked, that means slip is 10%. So then skidding will happen. That means you apply full brake force. Wheel is not allowed to rotate, but the vehicle was moving with some velocity. So it has some momentum. That momentum, because you are trying to stop it, correct? That's because by locking the wheels, so the vehicle will skid. That means then you lose direction control. You cannot steer the vehicle, and if you are not able to steer the vehicle will not stop, and it may go and hit the object in front without stopping. That should be avoided. Then a locked wheel does not provide lateral control, which is called steering. Y direction called steering. You cannot turn the wheel. Steering control is not possible. Then multiple wheel locking leads to yaw control, because you know the four-wheel vehicle, correct? One wheel can get locked if the brake is not applied properly, correct? Other wheels can be still rotating. In that case, vehicle can start swaying, correct? So if you multiple wheels are get locked, then yaw control, the horizontal vehicle can start rotating on this one. That is called loss of yaw control. Then if wheel is get locked, the wheel will spin. Rear wheel moving towards front is called wheel spinning. First you lose yaw control. If the rear wheels alone get locked, then the vehicle can spin. Okay, I told you this graph shows the tire slip versus the braking force and as well as cornering force, which is called as lateral forces. Right? You can see that the slip as well as the braking force. Okay, the braking forces are shown in blue color. Right? These graphs are braking forces. Braking force. You may see, you may notice there are multiple graphs. You may wondering what it is. That depends upon the road condition. Correct? If the road, you dry road, concrete road, correct? This is the braking force, correct? As the slip varies from 0 to 10% in x-axis, if vehicle is moving on a dry concrete road, the braking force from 0, you can see that it is increasing and goes to a maximum value 10%. Correct? A maximum value braking force and start decreasing. And when the slip equals 10%, this much. That is the braking force available. Correct? When the dry concrete road. In terms dry asphalt road means you can see that the amount of the maximum braking force is always lesser than concrete road. Concrete road provides best braking force, correct, compared to asphalt. Then if it is a wet asphalt, you can see that it is still lesser. We are talking, see the braking force increases and coming down. It is not constant as the slip varies from 0 to 10%. So we can see that similarly for this, the road is whether wet asphalt road, then it may be concrete road or asphalt, but snow, correct? You know the Western Hemisphere, especially European country, America, Canada, Japan, China, parts of China, all those things. In winter, 3 to 4 months, lot of snow happens. On the road, if you have a snowy surface, you can see that the maximum brake force is much lesser, correct? So it becomes very less. Then if it is a snow, if you have ice is hardened snow is called ice. Correct? If ice is there, you can see that the braking force still reduces considerably compared to dry condition. So that's why in the wet conditions, when rainy conditions or snowy condition or thick ice on the road, which is sometimes called sleet, correct, is there, you should drive slowly because your brake won't work properly. Again, the braking force available also maximum occurs, you can see here this region. Right? This region, you get this one. Something around 15 to, it looks like a 14. Generally, they say best thing is around up to 20%. Right? There's a peak, you can say the peak performance. You can see this is the peak. Right? This is the peak value. Avails something around 15 to 20%. Correct? So that means you should see that the slip of the wheel, slip of the vehicle, wheel slip, correct, is always around this. That means if you apply more, then only when the slip is around that person only, you are getting maximum braking force. Okay. So the other one is the lateral cornering force, which is shown in as you can see that the red color is a lateral cornering force. Correct? Correct. That is also reducing. You can say all the whether the braking force or lateral cornering force, everything is maximum only for given road surface only in this region. That's why you have to maintain a wheel slip of around we can say 15 to 20%. Okay, you can make even 15 to 20%. Okay, so this is very important. So what is job of the ABS system? ABS system sees that depending upon the road condition, correct? Irrespective of road condition, it always try to maintain wheel slip around this value, correct? say 10 to 20%, 25%, so that the vehicle has the maximum braking force and without slipping, vehicle can be stopped. Okay. The ABS system, already I told you, it consists of wheel speed sensor and hydraulic pump, hydraulic control valve, and electronic control unit, because most of ABS system use hydraulic braking system. So we already talked about, this is the brake pedal. Correct. When force is applied by the driver, when force is applied by the driver, it actuates the hydraulic system. The hydraulic system, from the hydraulic system, you can see that the pressure, high pressure fluid comes to the modulating device. The modulating device is controlled by electronic control unit. Correct. The modulating device is controlled by the hydraulic modulating. That is, the fluid will be supplied to the hydraulic brakes whenever this one. And so the electronic control unit generates the modulating pulses. I will show in the next slide. Okay. The wheel speed sensor is located on the each wheel, provides the wheel lock-off information to the ECU. What is the main job of this ABS system? The ECU always monitor if wheel is about to stop, lock, that is called locking condition, it prevents. So it should release the brake. So the hydraulic pump and valves provide necessary braking pressure. Okay, braking pressure whenever it is necessary. Okay, there's a valve on each brake lane, as I already saw it, and controlled by ABS controller or ECU. These valves are used releasing the pressure applied to brake shoes to avoid lockup. Correct. There are two sets of valves. One set of valve opens, applies high pressure fluid to stop the wheels. Once the wheel is about to go, that valve is closed, and another set of valves opens, that is called release valve, and which removes the high pressure fluid from the this one and returns. Correct. So returns the fluid back to hydraulic reservoir. So that's how it goes. Then electronic control unit receives information each wheel. In turn, if the wheel loses traction, when it loses traction, when the wheel is get locked, so the signal is sent to the controller. The controller will limit the brake force by releasing the fluid, and ABS modulator actually braking valve on and off. So it on and off by this one. Right. So already this one, already we saw this figure. Correct. Slip versus braking for cornering. We show the best is around this region. Correct. So the braking force also maximum. The cornering force also is only this region. Correct. So that is for lateral control. Correct. So this is how the pressure is working. You can see that you apply brake here. What happens is at this time T equal to 0, the driver presses the brake pedal. You wanted to apply brake pedal. That's it. Driver just presses brake pedal. There's a sensor at the this one which sends a signal to the ECU. Correct. Once it's applied, then you can see that hydraulic valve is opened by the ECU. Correct. Hydraulic valve is open. The hydraulic valve is open by ECU. So ECU, so that the hydraulic pressure is applied on brake shoe. So the brake force is increasing. Correct. When the pressure is increasing in the high pressure line going to the brake shoe. As this one, you can see that the wheel speed is correct. Wheel speed is reducing because wheel was rotating with the maximum speed at the given instant. For example, 100 rotations per minute or something. Correct. Even more can be maybe 200, 300, depending on the vehicle speed. Okay. So the speed, because brake force is increasing, so you can say wheel speed is reducing. When brake force is 0, wheel speed is maximum. That means no braking. As the fluid pressure, brake force is increasing because pressure is increasing. So the wheel speed is coming down. When as the wheel speed is reduced, you can see that the vehicle speed is also coming down. Blue line, correct? Now, at this instant, if we go on apply pressure, correct? At this pressure, wheel get locked. We stop this one. This should not be allowed, right? If wheel gets locked, right, then skidding happens, correct? Skidding happens, and after some time, vehicle will be stopped. The skidding happens slowly. You lose energy and stops. But this is not should not be allowed, right? The skidding should be avoided. What you have to do, you when around this time itself, right? When wheel speed is coming down somewhere, you can still maybe steeper. I will show it. Maybe somewhere here, right? So wheel, this is not wheel. Still wheel is rotating. At this juncture, the ECU will, electronic will release the brake by switching cut off in the hydraulic pressure. Okay, then wheel speed will again start increasing from here. Right, it will start increasing to value. Right, after some time again this will apply. The brake force will be applied. Again, next cycle starts. Right, so next cycle starts, and like by doing repeatedly. Correct. Here the brake is on. Brake on from here, correct? Brake is on up to this, then off. Again, brake on. Okay, this is brake on. So repeatedly doing, the vehicle speed will brought to 0. Already, that's what already we saw. Here I am showing finally, quickly I will show this. So how the ABS works, this is a flow chart, please note down. So every time, this is next time, you apply the brake pedal pressed. You are applying driver. Who is the driver is doing this? Driver press a brake pedal at K equal this one. What will do at this one? The immediately vehicle speed is measured, because we know that the vehicle speed also should be, because vehicle has to come to standstill, correct? Vehicle speed is measured. Okay, then we want to see whether vehicle speed equal to 0. How will you know the vehicle speed? By measuring wheel speed. Correct. Wheel speed sensor is used for both. Vehicle speed also you can measure. Correct. Also number of rotation making. Then also number wheel. Okay. From through wheel speed sensor. Okay. Then if vehicle speed is not, if is 0, correct, you can stop it. Otherwise, you know means you send, correct. Here, what we are saying, vehicle speed is greater than 0. 0 means you have to stop. If it is not 0, yes, it is not 0. Go to next step. Next step, what is the minimum speed? Because we need to see that the vehicle, the wheel should not be get locked, right? So next step is we check what is the minimum speed. This is set speed is equal to or less than minimum speed is this one. Check. If it is yes means apply brake. Otherwise, acquire what is the omega. Then compute the wheel slip. Correct. We know that the wheel slip should be here. Wheel slip is given as yes. Yes should be maintained between 10 to 20%, something like that. Right? How will you calculate wheel slip? This one. Acquire omega k. Then compute wheel slip. Once the wheel slip is computed, if computed wheel slip is equal to lesser than s, the minimum wheel slip, correct? Then what you do? Apply brake. Otherwise, no means if the wheel slip is greater than the are equal to maximum slip. We said that this is the minimum slip. Let's say min S, correct? We say S min. This is the S max. So we want to maintain within this. That's what we are doing. We are trying to check whether we calculate we know the vehicle speed, then we know the wheel speed, correct? Then compute the slip, check the slip value, whether within the minimum or maximum value, accordingly try to do the next step, correct? So then if it is within the release the brake. So go. This is how the ABS works. Okay. 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 3 more slides. I think we'll complete this also quickly. So how is this one? There's a controller which is nothing but ECU, electronic control unit. You can model, correct? ABS system, you want to do a simulation, you can model. This is ABS modulator. That is brake pressures, which in turn is given to wheel dynamics, correct? Wheel dynamics, a model of wheel, mass of vehicle, all those things come in picture. So this is vehicle dynamics, wheel dynamics. So wheel dynamics talks about wheel speed, correct? Vehicle dynamics talks about the vehicle speed. Okay, so the controller receives both, right? It measures. This is the vehicle speed, right? So this is also coming as input. This is also coming to as an input to the controller. It measures both wheel speed and the vehicle speed and calculates the slip. Accordingly, it modulates the pressure so that whether brake to be applied or released. Okay, so the wheel is controlled. So you can use a PID controller. The simplified longitudinal model of a vehicle dynamics can be given as M into Vx dash. Vx dash means this M is mass of the vehicle. Vx is nothing but acceleration, correct? V is the velocity vehicle. V dash is nothing but x direction. When we are talking about vehicle is moving, this is x direction. Vehicle is moving, correct? So vehicle movement. So velocity in the x direction. Here dash means acceleration is nothing but MA, correct? We know that MA is nothing but minus V sigma I equal to 1 to 4 FTI minus FA, where M and Vx are the mass of the vehicle and longitudinal velocity of the vehicle, respectively. FTI is the road frictional force between each wheel. That's why I is 1 to 4 means 4 wheels, correct? You have to substitute. And sigma of this one. And road surface, and FA is called aerodynamic force. Okay, where FA can be calculated using sigma air density. We are talking about air density divided by 2 into CD into AF into Vx square. Vx is the vehicle velocity. Vx is the vehicle velocity. Okay. AF is the frontal. AF is called frontal area of the vehicle. Frontal area of vehicle, which opposes the flow of air because vehicle is moving forward. CD is a constant. CD is a constant. This is called a drag coefficient, actually. Drag coefficient of the vehicle, correct? How it is desired depending upon shape, correct? So drag coefficient is less when vehicle is a sports vehicle. You can see that if the vehicle is moving, something shape is something like this, a car, right? Now air is coming from this direction. So if it goes, this kind of sports car. But if you see a bus, correct? Bus, how it looks generally, something a boxy structure, correct? There are wheels, right? So here, this CD for the sports car can be as low as 0.27. Lower is better. Okay, we want drag force should be FA should be lesser and lesser. So CD for this may be around 0.7 to 0.8 for bus, which is a square frontal area. Then what is AF? This area is called AF, the frontal area. Here the frontal area will be, because the shape is something like this, correct? So the frontal area is less. This correct. This is a curved surface, so the frontal area you need to calculate, correct? Considering the shape of this one. So for sports car, this is a sports car, correct? CD will be around this value, 0.2, 0.25, something like that. Bus, all the boxy structure, correct? Bus, truck, all using, because if you make like this, why you want to bus? You want to put more volume inside, more number of people, luggage. Then you cannot make this kind of shape, correct? So that's what it is. FT is nothing but, as we are talking about, frictional force between tire, correct, under the road surface, which is mu into lambda I into Fn. This is the Fn is the normal force acting that depends upon the weight of the vehicle, right? Weight of the vehicle decides Fn, correct? Normal force, because mass into acceleration, correct? Gravitational acceleration. Mu is the frictional constant. Okay. Okay. I is 1 to 4, correct? Because of 4 tires. Okay. Then assuming that there's no drastic change in the height of the road, so with a flat road, vehicle is moving on a flat road, thinking that vehicle is moving on a flat road, correct? So there's no surface steering and no steering, the roading moving in the straight road, and you are not applying brake, then it can be approximate a static model of a load of each vehicle. F1 equal to this much, the Fn2 equal to this. The two, if for front wheel, this is a rear wheel, where C in this equals C11 equal to G by 2, C12, you can note down. Where AX is a longitudinal axle vehicle, LF is the distance between center of gravity, all these things. Once you know this vehicle, the information, you can do simulation. That's what we are trying to say, correct? So then finally, during the braking, wheel slip, correct? Wheel slip lambda I, because individual we are taking, and the differential value of the wheel slip lambda dash, okay, here dash is not visible, can be calculated by lambda is wheel slip. Previously we said yes, here in this equation we have same thing, this is wheel slip, lambda is nothing but vehicle velocity minus wheel velocity, ith wheel, because each wheel can rotating a different speed, wheel speed, divided by vehicles. Vx is vehicle speed in x direction, the longitudinal direction, minus individual wheel speed divided by this will give wheel x, which can be calculated like this, correct? Where is the Rw is the wheel radius, W is the angular velocity of the wheel or each wheel, and Vw is nothing but the wheel speed, okay? So when wheel slip condition is 0, the wheel and vehicle will have same velocity. When wheel slip condition 1, the wheel is locked. When the wheel is locked, the vehicle is no longer steerable and a smaller frictional force than the vehicle, correct? So then you cannot control. Already we saw wet surface means the frictional coefficient become less, correct? This is mu, correct? And the previous equation we saw the mu, correct? The wet granite, and this is asphalt, dry asphalt, close to 1, correct? That's what we are talking. So these are meant only for simulation purpose. So this is the ABS control system we are talking. Already this is the reservoir, hydraulic fluid is there stored. Hydraulic fluid is stored in the reservoir. This will be pumped by a pump. There's a pump which pressurizes the fluid, sucks and pressurizes the high pressure fluid, correct? So high pressure fluid, which is connected to inlet valve, correct? You can see that this is inlet valve. When, correct? So there's a booster, correct? There's a booster which increases the pressure. This is the master cylinder. This is inlet control valve, okay? And then this is outlet control valve. So the high pressure fluid, when the driver presses the brake pedal, the pulses are generated. You can see the pulses, correct? There are outlet valve, correct, output 1 and output 2. Okay. Then this is a differential pressure, and when the driver presses the valve, correct, sorry, when the driver presses this is the pedal, brake pedal. When brake pedal is pressed, the booster valve acts and opens the master cylinder, which in turn allows the high pressure fluid to go to the wheel cylinder. Wheel cylinder presses the brake pedal, correct? So brake force, wheel stops, correct? Wheel speed is reduced. Then this is sensed by this when the pulse, this is there, correct? So this is on. Okay, which this one, this inlet valve, this is A valve. This I can say the A valve. Already we talked A valve. This is nothing but C valve, return valve, right? So whenever the inlet valve is open, this valve is closed, correct? So this is, so inlet valve is open, brake on, correct? That time you can see that this outlet valve, this is outlet valve, this is inlet valve. Okay, so this is C valve. C valve is closed, right? Then when brake, if you want to release the brake, the A valve is off. A valve on. This is A valve off. Exactly the opposite, correct? That is C valve is on, correct? Here C valve is on. Here the C valve is off. So now this is, you can see that the duration on off is varied. This is called as modulation. It's called pulse width modulation. Pulse width modulation, PWM. So the brake, as the vehicle speed reduces, you can see that on time is the braking time is go on reduce. Correct. So here you have more braking force, more number of long duration. The brake valve is open. So brake force is applied. As vehicle speed comes, then this one. So this is the ABS control. This is very important. This valve, correct? The graph shows, correct? They call pulse width modulation. That's why you call modulator, correct? We saw in this everywhere we are saying ABS modulator, correct? So the braking force is not constant. It will go on as the vehicle speed reduces. The brake force should be reduced. How long brake is switched on will be reduced. So this is called, as the pulse width is varied, they call pulse width modulation. That's how the ABS works. We think we stop here. Next class we'll see about ABS, the cruise control.